Hello everyone, bonjour. Today we are going to look at some parametric equations. So, we will write it out here. You know how to spell equations, I'm not going to write that. Parametric. So, parametric equations are equations that your position, velocity, acceleration are dependent on your time. And they will tell you where you are when you tell them what the time is. So we will have an x equation. I'm going to give you one right here. And you will have a separate y equation. And when you put in the time, it will give you an xy ordered pair, and that will tell you where you are located. So I'm going to show you quickly how you can graph these on your calculator. So let me get this real quick. Now, come back to us. Here we go. Okay, so I'm going to go into the mode, and I'm going to go over to, whoops, that is not right. Over here, over to parametric. Now, when you go to y equals, you will see something new. There is an x and a y, both one, they go together. One is not separate from the other. You must have an x and a y to get your location. So 2. Now when I push the x button, look at this. Oh, it's a t. It is not an x anymore. Well, that is something. 5 sine t. Now let's get this y equation. 2 minus 5 cosine t. Now we got it. So if I hit the graph, we will hit this zoom 6 to start out. Well, this is a little boring. And you see it graph very quickly. At 0, it starts right here. And then as time passes, it moves around this way. Now, what you notice, you cannot see the time. There's no time axis. There is an X position and a Y position. You look like you're looking at a GPS screen from up above. This is all you see. There is no time on this graph. You cannot see it. It is hidden. Well, this is not a good picture. Let us get the window fixed. You see time as started time 0. You see T max, it goes up to 2 pi. That is very boring. We're going to change that to 12 pi. That's a lot more pi. T step is how often it will recalculate. This is probably pi over 24. I don't know, something like that is good enough. Now, my graph goes out to the right. So I'm going to change y max to 50. That is a good one. Here we go. Let's see. Look at this graph. It is springy like Tigger. And it starts here. It goes this way. So it has a direction in changing. Lots of excitement here. This is a good one. All right. So that is how you can graph the parametric equations. Most of the time, we will be dealing with the velocity equations. And because of that, graphing these velocity equations is not helpful. It does not give us good information. So, sadly, most of the time, we will not even be in this parametric mode at all. We will simply stay in the function mode and do all of our work there. But for the sake of you seeing some things, we will leave that up there for now. Now, I will come back to it, but let us blow this thing back up here. Okay, parametric equations can be written as individual equations like this, or you can write them in vector notation. Vector notation is like parentheses but pointy. And I will write 2t minus 5 sine t, comma, like an ordered pair, except it's an x equation and a y equation. Otherwise, it is the same thing. There we go. So that is a position vector for these two equations. You can write it one way, you can write it the other. It doesn't make a difference to nobody. But you got to be familiar with the both kinds. Well, what happens when we want a velocity? now we got a question. I better keep it so I can see it right here. The velocity vector, I put a little arrow for that. Guess what it will be? Well, if this is position up here, then velocity has got to be the derivative. So the derivative of the x equation is going to be 2 minus 5 cosine t. And the derivative of the y position function is going to be positive 5 sine t. So that is my velocity vector, has both the x and y velocity. So if I plug in the values here, it will tell me the velocity of the direction that I'm going. So for instance, if I want to know how fast is this moving at t equals 0, then I'm going to make a v with a little 0 here. 2 minus 5 cosine 0. Cosine 0, you know, is 1. So 2 minus 5 is negative 3. And I plug in the 0 right here into sine. 5 sine 0 is 0. You know this. So that tells me at the beginning of this problem, this little guy running is moving to the left at 3, we say meters per second. You can put whatever, you can do picometers per nanosecond if you want something more interesting. It has a no vertical velocity. It does not go up or down on the graph. It only goes to the left at that speed. So let us look at this picture. Right here, I see it moves to the left immediately. Scale on x and y are not the same, so it is a little bit stretched. If you change the scale so that equal distances for x and y on these little dashes, then it would look a little more just to the left. But it is only at this velocity at the instant 0. If you come to 1 second later, then it is going to be up here somewhere, and 2 seconds later up here somewhere, and it just keeps going as you go around. So instantaneous velocity at that instant, only moving to the left at negative 3 units per time, second, whatever you want. And that is the behavior that I see right there. Now, if we come back, I hope you get it now. If I want acceleration, oh, piece of cake. These problems is just like doing last year's problems, only we got to do 2 of them instead of 1. The acceleration vector is the derivative of velocity, and that is going to be 5 sine t. And the derivative of 5 sine t, the y velocity, is going to be 5 cosine t. And now we have the acceleration. So this is very easy. It is not a hard thing. If you say, oh, I want to know what the acceleration is at 0, or any time, you just plug in that value into these. So 5 sine 0 is 0. 5 cosine 0 is 5. Now, if you do some physics, you find out that the velocity, it tells you what direction you're traveling. On here, I see that I am moving at t equals 0. I'm moving to the left at that speed, 3 units per second. Acceleration tells you where you're going to be going. It is what is coming. And so this tells me, I can see it, that I am going to be, will be, or will go up is the direction that is coming. And when you look at this graph, you will see that happen. Beginning, I go to the left. In the future, I'm going to go up. And so that is how that relates. Okie dokie. Let's look at something else here. If I want to talk about some other things from the last video, we talk about the speed. And the speed is the absolute value or the magnitude of the velocity. And we know, because we got 2 dimensions, is going to be a Pythagorean theorem. That is not a problem for us. We are smart enough for this. So I can do square root. This is going to be a biggin. And let's see if I go x prime of t. Usually, in these problems they're going to give you on AP, they're going to use the x prime and the y prime. They don't use the v sub x and the v sub y. It is okay to use it, especially for me. It is okay. It is correct. But in the scoring guides, you will never see a v sub x or a v sub y. You will see x prime and y prime. You will also see, so that is my speed. I'll show you this notation in a moment. So x prime squared, the velocity squared for x, y prime squared is the velocity for y. You add them up, square root it, that is now your speed. This calculation will usually be something you want to do on the calculator. It is pretty easy, but a little bit messy. But good thing you guys are so smart, it don't make a difference. Now, for notation, whoops, got to put the marker down. All right. Notation, you remember, because you're so smart, that x prime t would be the same as dx dt, and this also the same as velocity in x. Y prime is the same as a dy dt, and that's the same as the velocity in y. The derivative of x with respect to time, this is the derivative of x with respect to time. This is the derivative of y with respect to time. This is the derivative of y with respect to time. So we got all that right there. And now you know how to find the speed. So if I give you a position, you can find the velocity, you can find the acceleration, you can find the speed. Most of the time, they're going to give you the velocity functions, the velocity vector. You can find the acceleration, you can find the speed. That's on almost every parametric FRQ. It's going to be on the test somewhere, and you're going to get it right. Now, that's the end of this video. I'm going to come back and teach you some more of parametrics in just a little bit, but I want to keep the video short and sweet. So I'm going to say au revoir and goodbye.